Today we're going to do Chapter 14, From Randomness to Probability. A random phenomenon exhibits random behavior. It has individual outcomes that are uncertain, but the possible outcomes are known and have a regular distribution after a large number of repetitions. Example, if I roll a fair die once, I can't predict with any certainty what number it will land on. But if I roll it 60 times, I can expect it to land on 1 approximately 10 times, on 2 10 times, on 3 approximately 10 times, etc. The probability of an outcome is the proportion of the times the outcome would occur for a large number of repetitions. Probability is the long-run relative frequency. Example, the probability of a die landing on a 4 is the proportion of times the die lands on the 4 for a very large number of repetitions. A random phenomenon consists of trials. Each trial has an outcome. Outcomes combine to make an event. S is our sample space. It is the set of all possible combinations of outcomes for an event. Example, for the event, roll a die and observe what number it lands on. The sample space contains all the possible numbers the die could land on: 1, 2, 3, 4, 5, and 6. Example 2, when flipping 3 coins, an event may be getting the result head, tails, head. In this case, the event is one outcome from the sample space. When flipping 3 coins, an event may be getting 2 tails. In this case, the event is the set of outcomes tails, tails, heads, heads, tails, heads, tails, tails from the sample space. An event is usually denoted by a capital letter. For example, we might call 2 tails event A. The probability that we get 2 tails could be written as P of A, which is probability of A. The law of large numbers says that in the long run, relative frequency of repeated independent events get closer and closer to the true relative frequency as the number of trials increases. Example, when flipping a coin, the relative frequency of heads is quite erratic in 2 or 5 or 10 tosses, but after several thousand tosses, it becomes very stable, changing very little over further thousands of tosses. Important, the law of large numbers does not apply to short-term behavior. Probabilities even out only in the long run, and the long run must be infinitely long to give them time to even out. Rules of probability. The probability of any event is between 0 and 1, also written as 0 is less than or equal to probability of A, which is less than or equal to 1. Probability of A equals 0 means the event will never occur. Probability of A equals 1 means the event will always occur. 2. Something has to happen rule. If S is the sample space, then P of S equals 1. One of the outcomes in the sample space will occur. The complement of an event is the set of outcomes not in the event. Complement rule is probability of A complement, which equals 1 minus the probability of A. Example, when flipping 2 coins, the probability of getting 2 heads is 1/4. The probability of not getting 2 heads is 1 minus 1/4, which equals 3/4. 4. Events A and B are disjoint or mutually exclusive if the events cannot occur together. They have no outcomes in common. The addition rule for disjoint events, the probability of A or B equals the probability of A plus the probability of B. The probability of A or B may also be written as probability of A union B. That capital U stands for union. Example, let A be rolling a die and landing on an even number. In event B, We roll in a die and landed on an odd number. The outcomes for A are 2, 4, and 6. The outcomes for B are 1, 3, and 5. These events are disjoint because they have no outcomes in common. So the probability of A or B landing on either an even or an odd number equals the probability of A plus the probability of B. Independent events. Events A and B are independent if knowing that one occurs does not change the probability that the other occurs. Multiplication rule for independent events is the probability of A and B equals the probability of A times the probability of B. The probability of A and B may also be written as the probability of A intersect B. That is, an upside down U stands for intersection. Example, rolling a yellow die and a red die. Event A is the yellow die, landing on an even number, and event B is the red die, landing on an odd number. These two events are independent because the occurrence of A does not change the probability of B. The probability then the yellow die lands on an even number and the red die lands on an odd number is 1/2 times 1/2, which equals 1/4. If events A and B are independent, their complements, A complement and B complement, are also independent, and A complement is independent of B. Disjoint events cannot be independent. If A and B are disjoint and A occurs, then B cannot occur, and the probability of B becomes 0. This means the two events are not independent because the occurrence of A changed the probability of B.